this module focuses on Python programming, but more specifically, some methods that I developed that I found especially useful in the development of IoT and cyber-physical related systems. This is not a programming course. We're not going to go into depth on the basics of Python programming. Hopefully everybody who's taking a look at this can either find another resource for that or is already familiar with that sort of object-oriented programming. But anyway, so what are we going to talk about? We're going to talk about three different methods that I specifically used when I was developing the XBee hardware. But it's really more general. It could be used for any sort of hardware software system that relies on Python for development. And so one part of this, there's three different sections. So one is going to be creating modules and calling external functions, a little bit of a review there. We're also going to talk about accessing data from an external text file, and this is a lot of formatting and sort of, formatting essentially, the data in the appropriate form and importing them into an array so that they can be parsed and accessed in Python. And then the third one is going to be creating and manipulating data as a CSV, a comma-separated file. And so these are three really important topics to understand if you're going to be working with Python within the realm of IoT and cyber-physical systems, because a lot of times you're going to have to take data, save it to an external resource, and in many cases that does use a CSV or a text file. So it's really important to understand how to go back and forth between those, importing, exporting, and properly manipulate them. First, creating modules and calling external functions. One basic skill that we're going to need for this work and anything that we're talking about related to IoT and cyber-physical systems is creating modules, which we can also call libraries, and calling functions from the libraries and other Python files. We're going to show a basic example, and the code below is part of a module that I just named after myself, dis.py. It contains a single function named invert. So this is probably bordering on the edge of basics of Python, but I did take some time to review it myself, and so I thought I would include it. As somebody who was not really familiar with Python before this, I had done a lot of work in C, C++, and Java. There wasn't too much of a learning curve with Python, but I think maybe this is one of the things that I explicitly pointed out. Okay, so what does our function look like? The function definition, pretty straightforward. We have definition of a function called invert. It accepts a single input called x. It inverts it, and then it returns the inverted result. Okay, now the second piece to this puzzle is the Python executable, which we're going to name call external function.py. This code will import the invert function from dis.py using this statement, from dis import invert. Okay, so we have from library name import function name. And then the code below shows us how to do this. Again, this is code that I developed myself. Okay, so we define our main executable. We import our function. We define a number, which we call a. Now, quick note here that the 0.0 is essential to defining the variable as a float. If we simply use 2, then the inversion will yield a value of 0 and not 0.5. And the reason for that is because the code is set up to return the same variable type that it accepts. So if we provide it an integer, it will invert it, and any value less than 0 or less than 1 would come across as 0. And we call our function, which now, if we properly imported it here, should just go ahead and be accessible to us, and then we display the result. And then we just call the main executable, and the result you can see is shown right here. So pretty straightforward, very easy one to start off with. Next, let's go ahead and jump into accessing data from an external text file. Now, For some work that I did before, I was doing some initial analysis and creating some configuration files in MATLAB and Microsoft Excel. And for certain applications, we may want to import that and use that in Python. So it's important that we understand how to save data collected from the XBees to a comma-separated file, CSV, as well as retrieve data from such files. There's two steps to this. The first step is understanding how to open and retrieve information from a basic TXT file. So that's why we have two different related sections. We're first going to talk about TXT files and how to parse them and recover information from them. And then second, we'll move on to CSV, which is really, I don't know what the formal definition would be, but it's fundamentally just a version of a TXT file with obviously commas used as delimiters. So if we can access a TXT file, we can access a CSV file, and then we'll take it one step further and learn how to manipulate it. Okay, so this is the text that we are going to be dealing with right here. And if this text is saved as sampleread.txt and uploaded to the Connectport X2. Now, Connectport X2, what is this? Like I said a second ago, this module was initially inside of the lessons related to XBee hardware. So that's the reason why I'm talking about the Export 2 X2. And if we wanted to call this code, we would have to, and use this text, we would have to upload it to that hardware. So if you've already gone over the section on the XBee, then that'll make sense. If you haven't, then just imagine that you're putting it in the same folder as whatever your executable is. That would be the requirement there. Because we are assuming, you'll see when we import the file, we're assuming that it's in the same path as our executable. Okay, several commands, including open, split, strip, and append, play an important role in accessing information from the external files. And we'll talk about those. All right, so the name of this Python file is called access.txt. I developed it. If you're wondering why I always put this up here, remember to turn off word wrap in Notepad. I was storing these before I started using Notepad Plus or similar sorts of very bare bones. It's not really an IDE. It's just sort of like a Notepad for coding. Anyway, before I did that, I was using regular Notepad, and the word wrap, if you turn that on, will change the formatting of your code, which is irritating. Okay, so let's jump in here. We define our main executable. We are going to import the proper libraries and modules, which in this case, all we need is OS. We're going to create arrays to store the lines from the TXT file. So we're going to try to split them by module A and module B and parse them accordingly. So these will go to the module A array, and these will go to the module B array. Next, we are going to use realpath, this command in the OS library, to determine the location of the sample TXT file. Because the files are uploaded to the Connectport online server, it's assumed that ZigBee and sample text occupy the same location. Now, like I said, we don't have to use the X2. We can simply place them in the same folder on your PC. Let's say you're using some sort of Windows-based compiler or IDE to run this, and the code will still work. Okay, so we extract our path using this command os path realpath, and we are putting in the name of our main executable, zigbee.py, and the reason for that is because, well, actually, I should make one change here. This is the wrong name. I think I might have renamed it. You should be using access txt.py. I don't know why I changed that name. Anyway, because that would be the location where it would be shared. Next, what we're going to do is we're going to display that path for the user, and then we are going to append the full path to the file name sampleread.txt to create a complete file name that may be used for access. Right? We know that we have the base of the path name taken from here, and then we are going to add to it the sample read.txt, and that will give us the full path, which then we can use right here. So the full path, file path will be the two of these combined together, the full path and sample read.txt. Okay, next, step 6, we're going to try to access the file at file path, which is the combination, well, we already said that. Okay, so we are trying, and the reason why we're using a try statement here is because we need to enable some error handling. Next, we use the open command in order to open the file at that given path, and that generates this object radio data. When you open in this manner, it is going to open it as an array where each line is going to be a separate element in that array. So if you think about what we have written up here, you will end up with an array where each one of these is a separate element. So the array will have 6 elements initially. Now we are going to examine each line of radio data, parsing through it using a for loop. And we are going to try to split each line by a colon. Now I write K1 line, but actually we are not indexing it in that way. We are indexing it by each line. Okay. And each line represents the element, not the index number. Hopefully you're familiar with this format for a for loop, where essentially you have for x in y, and what that does is it cycles through all the elements of y, and each one is stored temporarily to x. So each line will contain the first element the first time, second element the second time, and keep cycling in that way. All right, we are going to divide each line into 2 parts, the module name and the module data. So we're splitting each line by a colon, and that gives us the name and the data. Right, so if we go and take a look back up here, we're splitting here, 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 and here for each line. On the right-hand side, we will have the data. On the left-hand side, we will have the module name. So once we've split, all we have to do is, well, we're going to remove any spaces from the data using the strip command. And then we are going to save the data to the appropriate array based on whether the module name is module A. If it is, we append our data to the module A array. Otherwise, we append it to the module B array, and then we do our error handling and we close the data file, and we essentially print the results right there. And so what we end up with, as you can see right here real quick, the location is displayed, and the data transmitted by module A includes 3 different lines. Module B includes another 3 different lines, and all of this matches up with what we see at the very top, meaning that we have successfully accessed the information from the TXT file. So next, we create Python code that saves similar text to a TXT file, and we're going to name it the same thing, sampleWrite.txt, uses similar commands, and so here is the code. Okay, So what we're going to do is define our main executable. We import the same library. We're going to create now two different arrays that will eventually be saved to be saved as a txt file. We're going to use the real path command again to retrieve the path. Again, this is going to be based either on zigbee.py, which is a file that I had in the same folder, or we could use the access txt.py. Essentially, this command is relying on the assumption that the text and the Python file that we refer to right here are in the same folder. So we display the folder name. Again, we append the sample write.txt name to the file, to the path, which generates the full file path. And we are going to try in order to do something, again, to allow for error handling. And so we open the file at a given path, which is going to generate this array called radio data. We are then going to cycle through all of the elements of the array named module A up here. And we are going to use the write command in order to transfer that information from the module A array to the radio data object. So we transfer the information, we increment the counter, and do it all over again until we've reached the end of module A. Then we repeat the same process for module B. We close the file, and we need to handle any errors. We call the main executable, and what we end up with is an output that looks like this. You'll note that because of the way we wrote the information, it displays all the A's and then the B related information. Okay, the last section of this module is going to take this one step further and allow us to manipulate data as a CSV file. So this code demonstrates how to save a two-dimensional array in Python to memory as a comma-separated value file, as well as retrieve this information. It's composed of several sub-functions. So we have the function extract column, the function save data to CSV. So I should probably say what these are. So function extract column extracts a single column from a two-dimensional array and returns it to the user. Function save data to CSV accepts a matrix and a location to which the data structure will be saved in memory as a comma-separated value file. It provides both overriding and appending capability, allowing the user to retain previous information if desired. So what that means is we'll have the option of whether we want to overwrite what exists there or we want to append to it. And then we have a module or a function load data from CSV, and this performs the opposite of save data to CSV. It transfers the data from the CSV file to a two-dimensional array in Python. Okay, so we jump in here. We know that we are dealing with three different sub-functions. Let's start off with the first one. Function extract column. We pass to it both the column to be extracted as well as the full matrix from which we are going to extract that column. So this piece of the code right here is strictly Python focused, and it does not dive into the conversion between the CSV file and the matrix in Python, or the opposite, going from the matrix back to the CSV file. All right, so what we're going to do, and this is pretty straightforward, so I think I can really skip through most of this. Hopefully anybody who's worked with matrices and arrays in Python understands how something like this would work, right? You create an output array to hold the kth column. You go through and you cycle through the elements. You extract only the values that have the appropriate column index, and then you return the array. Hopefully there's no questions on that. That seems really straightforward, especially for anyone who has any experience working with Python. Okay, the next two functions are perhaps a little bit more difficult, not even necessarily in terms of the programming prowess that's needed, but just really in terms of the just the commands to be used and using these libraries. Okay, so the input is going to this function is going to be the matrix to be saved, the file path, and then a string telling us whether we're going to append or write the data. Okay, so we want to define two values based on whether write or append mode is to be used. One is the number of columns, or n calls, which is the number of columns of data to be saved to the CSV file. Another is int first new row, or the first row to which new data will be saved. The ways in which these values are defined depend on the mode. And it makes sense because obviously the first new row is going to be different depending on whether we're starting from new, we're overwriting. In that case, it would start from row 0 or row 1. And then if it's appending, then we would want that first new row to be at the end of the existing file. Okay, so let's start off with the assumption that we are appending. Okay, and if we're appending, we need to load the existing data. So we're using a function that we haven't discussed yet, which is going to be the function load data from CSV. We are going to talk about that. That takes the information from this file here and creates our matrix loaded data. Next, we're going to define the number of columns as the larger of the two values. Okay, the number of columns of the existing file and the number of columns of the input. Right, because if we have our existing file and then we have our matrix input, if one has 7 columns and the other has 5 columns, then we will obviously need to go with the larger of the two values. If we go with the smaller, what means is we're either going to be cutting off information from the existing database, or we're going to be cutting off information from our new data. And so we pick the larger of the two, and that's all done in here. Next, if we are appending, we want the first new row of data to be the length of the old matrix along the row direction. And so that's what we're defining here. We are not going to set int first new row to 0. We are going to set it equal to the end of the previous file. Now, else we have a new file. And in that case, we don't have to worry about this. We are going to set the number of columns to whatever our matrix in provides us. And we're going to set the first new row to 0 because we are starting from 0. Next step, we want to initialize the matrix data to save, that will hold all results existing and new. The number of rows will be equal to, and we already know this, if we're appending, it'll be the number of rows of the existing file plus the number of rows in the new input. If we're writing, then it's just going to be the number of rows in input. Okay, so right here we have, if we are appending, then the number of rows is simply equal to the first new row plus the number of rows in the input. That's the same as summing the two together, the two lengths together. Now remember, this is along the row dimension, which I'm imagining to be the vertical direction because that's normally the way that it's displayed. But okay, and then we want to initialize the matrix with consideration of the existing value. So what we're doing here is we're creating a new matrix and we're telling it that we have a range of columns. So that goes from 0 to n calls, and a range of rows that goes from 0 to the number of rows. Now, if you're unfamiliar with this syntax right here, you may have to take a look at a Python resource. So you can see it's structured not really as a matrix, but as a two-dimensional array, which is just generally how it's done in most programming languages. Okay, else, if we have a new file, we are going to simply just take the number of rows as whatever the number of rows is from our input, and we are going to create, essentially this command stays exactly the same. These two are exactly the same. It's really the number of columns and the number of rows that is going to change how the matrix data to save is initialized. Next, we are going to start transferring values from matrix loaded data to matrix data to save only if we're in append mode. So the first thing, or the next thing that we're doing here is transferring the old data, which is only needed if we are appending, right? If we are overwriting, there's no information to be pulled. So we cycle through the two dimensions of the matrix here, and then we pull the data from the existing to the new, which we are going to save. Next, step 21. We are going to transfer the new values from matrix input to matrix data to save, and this will be done after the existing values are completed, assuming they exist. So we cycle through the elements of our matrix, and we transfer the values from matrix input to matrix data to save. In both cases, you'll see that we're taking values from something and putting it into matrix data to save. Values from something and putting it in to matrix data to save, because this matrix data to save is going to be that which is ultimately fed well, as an output and saved to either the hard drive, or this example is still sort of assuming that we're using the Connectport X2, but that's neither here nor there. We open a file with appropriate write access. Remember, we defined our string file path above. And then what we're going to do is cycle through all the rows of the matrix, where K1 is our row number. So we're using a for loop here. Then we're going to cycle through all the columns, and we are going to write each element in a matrix row to the same row of the data file. So you're seeing that we are going to use the write multiple times. There's an inner loop here where it's writing for K2. And then when we reach the end of a row, we start a new line, which is indicated by the \n, and then start the loop again. So the reason why things that are in columns will end up showing on the same row is because there's no \n to separate them. When we want to start a new row, as would be associated when K1 is incremented, then we start a new row by calling the \n, writing that, and then we close our data file. And that will essentially write our data to the hard drive. Now, this last function here is loading the data from a CSV. And since we are now familiar with a lot of these commands, I think we can fly through this one. Again, you have the data and the comments as a resource. So we import the appropriate libraries. We open our data with the appropriate file path. We initialize our two-dimensional array to temporarily store the data coming in from the CSV file. We're going to initialize a variable to store the number of rows. And we are going to initialize an iterative variable, which actually it looks like we do not end up using, at least not here right now. So we're not using this. at the moment. And the reason for that is because we decided to use this form of the for loop where we're pulling out individual elements and cycling through in that way, as opposed to K1 equals 1, 2, 3, 4, 5. Again, each element is going to be taken from data to load and put into each line, and then each time it increments, it'll load a different value. All right. So this is a CSV file, so we are going to split the line by the commas. We're going to strip away any spaces from the data, and then we are simply going to, while we're cycling through the elements of temp data, which represent, so K2 represents the column index. And all we have to do is just keep appending new values to our array. And once a row is complete, we append the semicolon separator, which is going to indicate the separation or beginning of a new row. We increment that row number, or we increase the number of rows. And then we are going to calculate the number of columns in the CSV file using this formula below. This is pretty straightforward, right? It's the number of columns is going to be equal to the length of the array loaded data divided by the number of rows minus 1. So just to do a really quick example, let's say we had something that looked like this. So like this right here, okay, you can see that we have 3 rows and 4 columns. The length of this array total will be 12 elements. So that would be returned right here. The number of rows we have already determined is going to be 3 rows. Now, if we calculate the number of columns, it'll be 12 divided by 3 minus 1, which would be 4 minus 1, and that gives us 3. Why are we getting 3 and not 4? It has to do with the way that I wrote the code. So essentially, the indices are 0, 1, 2, 3. So I probably should have renamed this. This is actually the index for the final column as opposed to the number of columns. But hopefully that makes sense. So index for final column, not necessarily, well, not the number of columns. Okay. All right, so we initialize our matrix called matrix loaded data array with the appropriate number of columns and rows. Again, I encourage you to take a look at this or take a look at a resource focused on Python if you have questions about this initialization. And then run through another loop here, which hopefully I can skip because we've already explained this kind of loop several different times. We run through everything. We append the values to our matrix loaded data array, and then we return that. And that provides us the ability to load data from a CSV, and that's the third of the 3 functions that we're discussing. So that marks the end of this module on Python programming, or more accurately, Python concepts that are relevant to IoT and cyber-physical systems, mostly dealing with importing and exporting data, which is an important skill to have if you're working with large data sets and you need to load and save different subsets of the data at different times. So hopefully this will be useful to you in your work, probably most applicable to the XBee radios, but there'll be a couple other spots as well where we talk about Python programming.